All right, number 13. Using that same idea, the next term will always be the rule applied to the previous term. That says previous in red. All right, well, we know the zero term, the seed term, which is 1. So to find the very next term, which will be x sub 1, we'll do negative 3 times the previous term, which is 1, plus 2. So the first iteration is negative 3 plus 2, which is negative 1. The second iteration, we'll do negative 3 times the first iteration. Always uses the previous term, the one before. N plus 1 is always 1 bigger than n. Second term, first term. It's always that way. Well, not exactly always, but for every recursive equation we see in this class, it will be. Don't forget the rest of the rule, plus 2. So the second iteration is negative 3 times the first iteration, the previous term, which is negative 1, plus 2. So the second iteration is negative 3 times negative 1, which is positive 3, plus 2, which is 5. All right, let's go for x sub 3. For the third term, that's the next one, we'll use the previous term, which was 5, and apply the same rule, negative 3 times previous, increased by 2, which is negative 15 plus 2, which is negative 13. What about the next term? That will be negative 3 times the previous term, increased by 2, which is 39 plus 2, or 41. Finally, the fifth term, it's negative 3 times the previous term, which is negative 123 plus 2, which is negative 121. All right, new rule. When the seed is 1, find the first 4 iterations. So let's use the seed of 1, square it, subtract 2. That's 1 minus 2, which is negative 2. What about the next iteration? Next iteration, we'll use the previous term, which is negative 2. The second iteration, we'll use the previous term, which is negative 2. It will square that, which is 4. And 4 minus 2 is 2. All right, what about the third iteration? Third iteration, we'll say, what was the previous term? Well, that was a 2. So the previous term will have the rule applied to it. When you square 2, you get 4, and 4 minus 4 is 0. And finally, this could go on forever, but this problem only asks for the first 4 iterations. So for the fourth iteration, again, we'll use the previous term and apply the same rule to it. The previous term was 0. When we square that, we get 0, and 0 minus 4 is negative 4. This is an interesting one. I'd almost like to see what happens after that, because I don't quite see a pattern yet. We went from a seed of 1, negative 2, positive 2, 0, negative 4. This is some interesting behavior. Maybe we'll look later if I have time see what happens in iteration 5 and 6 and 7. All right, let's go over to part 2. All right, let's look over at this one now. New seed. Seed is 2. So to find x1, we'll use the previous term, which is 2. We'll square it. 2 squared is 4. 4 minus 4 is 0. What about the second term? For the second term, we'll use the previous term, 0. That's what recursion always does. All right, so when the previous term was 0, 0 squared is 0 minus 4, because it's negative 4. What about the third iteration? Well, that's going to use the previous term, which is negative 4. When you square that, we get 16. And I just realized this entire time I've been subtracting 4? Why didn't anybody stop me? It's supposed to be 2. I'm going to have to back up. Oh, brother. All the way back. All right. When the seed is 1, 1 squared is 1. 1 minus 2 is negative 1. Second term, we'll use that negative 1. We'll square it, which gives us positive 1. 1 minus 2 is negative 1. The third term, we'll use that previous term, which is negative 1. We'll square it. Negative 1 squared is 1. 1 minus 2 is negative 1. It looks like we are stuck. It will always be negative 1. All right, now let's go over to this one. New seed, same rule. The seed is 2. What will the first iteration be? 2 squared, which is 4, minus 2, 2. What will the second iteration be? Let's use that previous term right there, 2. Square it. Oh, 2 squared is 4. 4 minus 2 is 2. Looks like we'll be stuck in this loop again. Every iteration will be 2. Interesting, in the first one, part 3 I guess, every iteration was negative 1. Same rule, different seed, and now every iteration is positive 2. What happens when the seed is 3? First term will be the previous term squared, which is 9. 9 minus 2 is 7. What about the second iteration? The previous term squared is 49. 49 minus 2 is 47. Oh, this is some different behavior this time. Looks like it's growing pretty quickly. Third iteration will be the previous number, 42 squared. Minus 2. 1762. And finally, the last one that's asked for, the fourth iteration, will be the previous term squared, decreased by 2. Which is 3,104,642. Let's stop there. Finally, part 4 again. New seed, 1/2. Alright, so the first iteration will be that seed squared minus 2, which is a fourth minus 2, and negative 1 3/4. Second iteration will be negative 1 3/4 squared decreased by 2, negative 5.0625. Third iteration will be that value squared decreased by 2, which is negative 27.6238. Well, now at this point, I've made a mistake that actually a lot of students often make. It's in the calculator up there in the top. Negative 1.75 squared. And, the way I entered it, I did not get the correct answer. The negative 5.0625, that's not correct. So let's erase it. And what was this common mistake made on the calculator? The calculator interpreted that as 1.75 squared, and then it took the opposite of it. Just following the order of operations, squaring before multiplying by the negative 1. So we want to make sure we explicitly tell the calculator that it's the negative 1.75 that we're squaring, and then decreasing by 2. So that the second iteration is actually 1.0625. And the third iteration will be that squared decreased by 2, or about negative 0.87109.375. And finally, the fourth iteration will be that squared. Remember, when it's negative, be sure to include it in parentheses. Decreased by 2. Negative 2.7588. Well, unlike the other three, this behavior is not converging to a constant like negative 1, negative 1, negative 1. It's not converging to 2, 2, 2, 2. It's not exploding like 7, 47, 1,762, 3 million, etc. This one's staying pretty close to small numbers, pretty close to 0. In fact, it's toggling between positive and negatives. You notice that the positive 1/2, the negative 1.75, positive, negative. Oh, this stayed negative again. This behavior is very interesting, very different from all the other ones. Let's stop there for now.